So, in the previous videos, we are just going through the chapter number 4, that is metals and non-metals. So, in the previous video, we have just started the chemical properties of metals and non-metals. In that, we have seen when the reaction of oxygen, when the metals and non-metals reacted with oxygen, what we get. So, in metals, we have seen that when metals reacted with oxygen, then we get metal oxide. Metal oxide. Okay, students, we get metal oxide, and also we have seen the example that was sodium plus oxygen, 4Na plus O2. When reacted, we get 2Na2O, that is sodium oxide. Okay, we get sodium oxide. And in non-metal, when non-metal reacted with oxygen, then we get, that is non-metal oxide. Okay, so in that also we have seen the examples of carbon plus oxygen. When the carbon is reacted to oxygen, we get carbon dioxide. Okay, we get carbon dioxide. So this we have seen in the previous video, but here I am just reading and just revising that orally, all the things. See here, the chemical properties of metals and non-metals. Chemical properties explain how a substance can change into a completely different substance. Metals and non-metals react differently with oxygen, water, acids, base, etc. and produce new substances. Reaction with oxygen. So most metals combine with oxygen to form metal oxide. See here, metal plus oxygen gives metal oxide. Okay, and see here, sodium is highly reactive metal. It reacts spontaneously and vigorously with the oxygen present in the air to form sodium oxide. It catches fire if kept exposed, and for reason it is stored under kerosene. Okay, so it don't react with the oxygen in the air, so it is kept in the kerosene. And here the reaction is 4Na plus O2 gives 2Na2O, that is sodium plus oxygen gives sodium oxide. Magnesium reacts with oxygen of air only on heating. It burns with a dazzling white light to form magnesium oxide. So when 2Mg plus O is reacted, then we get, that is 2MgO. Okay. Another is non-metals. Non-metals reacted with oxygen to form non-metal oxide. So non-metal plus oxygen gives non-metal oxide. And here the example was carbon plus oxygen, then we will get carbon dioxide. And sulfur burns in oxygen of air to form a pungent suffocating gas called sulfur dioxide. And that is S plus O2 gives SO2, that is sulfur dioxide. And these are also called acidic oxide, as they form acids when dissolved in water and turns blue litmus red. So this thing means this carbon dioxide and sulfur dioxide, the non-metal, when reacted with the oxygen, we get non-metal oxide. When this is dissolved in water, then we can get the acidic oxides, that are carbon dioxide plus H2O. We will get carbonic acid, that is H2CO3 and SO2 plus H2O, sulfur dioxide plus water, we get sulfurous acid. Okay students, now moving forward with reaction with water. Now we will see a reaction with water. Up till here we have seen reaction with oxygen. So here reaction with water. Reaction with water. Okay, so here when metals reacted with water, then what we get? See here, metal plus water, that is, we can also write H2O, then we will get is metal hydroxide plus hydrogen gas. Metal hydroxide plus hydrogen gas. Okay, plus hydrogen gas. Here the examples are sodium plus water, we get sodium hydroxide plus hydrogen gas. So here when 2Na reacted with H2O, then we get metal hydroxide, that is 2NaOH plus hydrogen gas. Okay, here 2 moles of water and here it is 2H2 and again the 2H2 is released, hydrogen gas. Okay, when sodium is reacted with water, then we get, that is sodium hydroxide plus hydrogen gas. Okay, now the another example in this is magnesium. When magnesium, that is Mg, reacted with 2H2O, then what we will get? Magnesium hydroxide, that is MgOH twice, MgOH twice plus H2, that is hydrogen gas. Okay students, see here I am just reading reaction with water. Most metals react with water to produce a metal hydroxide and hydrogen gas. Some metals react with cold water while others require hot water or steam. Metal plus water gives metal hydroxide plus hydrogen gas. Okay, metal plus water gives metal hydroxide plus hydrogen gas. And next is sodium. Sodium reacts vigorously with cold water to form sodium hydroxide and hydrogen. A large amount of heat is released in this reaction as a result hydrogen gas catches fire. So 2Na plus 2H2O gives 2NaOH plus H2. So sodium plus water gives sodium hydroxide plus hydrogen gas. And magnesium reacts with steam to form magnesium hydroxide and hydrogen, that is Mg plus 2H2O gives MgOH twice plus H2O. See here, the metal hydroxides are basic in nature and turns red litmus to blue. So metal hydroxides are basic in nature, which converts red litmus paper to blue. Okay, metals such as copper, silver and gold do not react with water under any condition. Means there are some metals which do not react with water, which are the copper, silver and gold. They don't react with water and don't form metal hydroxide. Okay students, and non-metals do not react with water. See here, non-metals do not react with water. So here in this topic, that is reaction with water, we have seen that when the metal reacted with water, then metal hydroxide plus hydrogen gas is released. But here in the non-metals do not react with water, and the examples of metals are when sodium reacted with water, then we will get that is sodium hydroxide plus hydrogen gas. Okay, when magnesium reacted with water, then we get magnesium hydroxide plus hydrogen gas. And we know that there are some metals which do not react with water. They are copper, silver and gold. They do not react with water to form metal hydroxide. And the non-metals, any of the non-metals do not react with water to form the non-metal hydroxide. Okay students, so here we have completed our topic, and our next topic is corrosion. Let us see that. So first of all, what is corrosion? In Gujarati, if there is corrosion in iron, then we can say that in Gujarati that is kaat lagi gyo. Ama kaat lagi gyo. We can say na that. So in different metals or non-metals, all the different is called. So let us see first of all what is corrosion. See here. Have you ever observed iron objects turning reddish brown color and silver jewelry turn black with time? Iron and many other metals such as copper and silver react with oxygen or atmospheric gases and moisture present in the atmosphere. Okay, so this phenomenon is called the corrosion. See here, in the corrosion, a definition is given. Corrosion So the process of slow and gradual degradation of a metal due to its reaction with atmospheric gases and moistures on its surface is called corrosion. Okay, it is called the corrosion. So the process of slow and gradual degradation of a metal due to its reaction with atmospheric gas and moisture on its surface is called corrosion. Okay students, it is known as corrosion. It happens in most of the metals. So Here, first there is an example of iron. So here, iron reacts with oxygen and moisture present in the air to form reddish brown substance called rust. So rust can be seen in Gujarati, that is kat. Okay, students. So I am just writing what is rust over here. So iron reacts with oxygen and moisture present in the air to form a reddish brown substance called rust. So when iron is reacted with the atmospheric gas and the oxygen which is present in the atmosphere and the moisture which is present in the atmosphere present in the air to form a reddish brown substance called rust. So we know that when the iron is open and when the oxygen and the moisture both just react with that and just it becomes forms a reddish brown substance called rust. In Gujarati that we told is kat. Okay, so to prevent the iron from the rusting, we know that all just paint. So if we just paint the iron, okay, then what will happen? It will not react with oxygen and the moisture. So all we do is paint on the surface of the iron. See here it is written in your paragraph, textbook paragraph. So here rust cannot stick to the iron object and keep on peeling. This exposes the fresh metal for further rusting. It due to course of time iron objects becomes weak. Okay, so iron objects will become weak due to this. And the another is copper. Copper object forms a thin green layer on its surface with time. This is due to reaction of copper with carbon dioxide and moisture present in the air. This green layer is called basic copper carbonate. So copper objects just form a greenish layer on the surface of it. So that is known as copper carbonate. They just oxidize. Okay. See here I am just reading it again. Copper forms a thin green layer on its surface with the time. This is due to the reaction of copper and carbon dioxide and moisture present in the air. This green layer is called copper carbonate. Then coming to silver. Silver objects turn black and lose their luster with time. This is due to the reaction of silver with hydrogen sulfide gas present in the air. So silver objects which are there, they after the time they just become blackish. Okay, so after the time, as the time is running, they will become blackish. Okay students, so what it is known as silver is reacted with hydrogen sulfide present in the air. Okay, so the silver is reacted with the hydrogen sulfide gas which is present in the air. Due to this, the surface of the silver becomes blackish after some time. Then coming towards why doesn't aluminium get corroded with the time? See here, the aluminium doesn't corroded with the time. Why? They have asked. See here, aluminium in the presence of atmospheric gas and water forms a protective aluminium oxide layer over its surface. The layer of the aluminium oxide does not flake off and sticks to the metal. This prevents the metal below the layer of the exposure to air and water. This layer makes an aluminum corrosion resist layer. So here the aluminum forms a layer on its surface that it will not allow to react any of the atmospheric thing, and it will not resist, it will not corrode. So what the aluminum corrodant resist layer is formed over the surface of the aluminum, so the aluminum is not corroded. Okay, and moving towards next, that is reaction with acids. Okay, we will see one by one that, but the reaction with acids we will see in our next video. So in your homework, what we will do is, you have to write the corrosion definition of corrosion, rust, and why the aluminum is not corroded. Why the aluminum is not corroded. Okay, this you have to write in your homework. Okay, students. So we will meet in the next video. Okay, bye students.